ones are exactly the same. So 6.6 is put into a separate section, and it really is exactly the same as what we were doing in 6.4. You're finding out what the max is, what the min is, what the axis is, what the period is, and then making an equation and answering the question. So here, again, I put the little equations up here. They're not really equations, it's kind of how I calculate it, right? So you don't have to memorize it. This one you kind of need to memorize, but these ones I kind of do it by understanding, right? Halfway point is when you add it, divide by 2. The axis, right, you add them, divide by 2. The amplitude would be when you take the difference, divide by 2. But if you want an equation, that's kind of what I go with. This one's saying it's tides. So the tides are doing this, out, in, out, in. So anything that's doing this can be made into a sinusoidal kind of graph. So we're going out, in with the water. On the day of October, the tides have a high point at 10 meters at 2 p.m. So there you go, that's the max. So we already have the max. I'm going to highlight that. So we know it's 10 at 2 p.m. The low point is at 1.2 at 8:15. This is all approximate, right? So whenever we do these graphs, they might not be perfect sinusoidal graphs, but they're approximate. They're good enough, and we're going to get the shape out of it. I like to draw it just because, again, I like to visualize it. So I'm going to do a little sketch here on the side. You don't have to, but I'm going to draw it just so you can kind of see what I'm getting out of this. Okay, and again, you don't have to do a sketch. I'm going to do it for myself. So it's going from the 10 down to the 1.2, right? So it's 10 to 1.2. And we've got a particular sailboat has a draft of 2 meters. That means, and again, you're like, what's that mean? The next sentence says, that means it can only move in water that's 2 meters deep. That means underneath the boat is 2 meters deep, and it needs that amount of room to be able to float by, right? Because otherwise it's going to scrape the bottom, or I don't know. All I know from boats is movies, so I'm thinking bottom of the boat, where you know the whirly thing, like, you know, needs room. So boats, I don't know about. But they're saying at least 2 meters deep, so this one is what we're testing. So based on those words, I'm looking to make sure it's 2 meters deep. The captain of the sailboat plans to exit the harbor at 6:30. So what we want to do is get the equation. So what we want to do is make an equation, then sub the time to find the height. Okay, so that is my thought process. Is like, oh, okay, so you basically, I'm finding the equation, then I'm going to sub in the time, which is at 6:30, to find the height to make sure it's more than 2 meters and compare that it's 2 meters. Okay, so we know the strategy. So I need the axis, so I need everything here. You can do it off this just by counting, but I'm going to do it and say, okay, so I know at 10, it's starting here at 10 o'clock at 2 p.m., and it does something like this, goes down, and it comes back up. So this is what we're envisioning. Yes. Oh. Good. All right. So then can we do the axis first? So we're going to do the axis, which is going to be 10 plus the 1.2 divided by 2. I got 5.6, which is the y is 5.6. So that means this line here is 5.6. So that one there. Okay, and again, you don't need the diagram, the calculations. You can do, some people just do little calculations on the side and start putting it into the equation. I'm showing you my process. Okay. Then I'm going to do, so that's my axis, the amplitude. I find the difference, so 10 minus the 1.2 over 2, which is 4.4. So I know it's got, this is 4.4 from here to here. 4.4, so we're good there. I need to figure out the period. Right, so let's figure out what the period is. So for here, I know that this is at what time? 2 p.m.? 2 p.m. The lowest point is at 8:15. So that's 8:15 p.m. But 2 and 8:15, you can't put 8:15 into an equation, right? So you have to tell me how many minutes is that? But then all the way through, so I'm going to say, okay, so then I know that this part here is 6 hours and 15 minutes. All right, but I want the whole thing, don't I? I don't want just that portion. I want the whole thing from here to the end. So I want the whole period. See how that's half? Does that make sense? Right? So that's half. So I want 6 hours 15, so double it. That would be 12 hours and 30 minutes. Is that okay? And now convert that to a decimal, right? Because we can't put hours and minutes into the equation. So that would be 12.5 hours. Good? So 12.5. So my period, and this is my period. That's my period. Yes?
Miss, how would you know you wanted it like in hours or?
You can do minutes. Yeah. So you can do the whole thing in minutes if you want. So you can do times 60 and do it in minutes. Yeah. Yeah. It's half, right, from the 10 to there. Does that make sense? And then, yeah, and you can do it in minutes. Yeah, for sure. Yeah, so the whole thing can be done in minutes or hours. I thought hours might be a little easier. Yeah. But yeah, you can definitely do the same equation in minutes. Yeah. All right, so now you have the period. You have to find K. Every time you find the period, remember, it's not K. We're going to find K. Leave a bit of room because we also want to answer the question. Right, so we're going to find K and then answer the question because we got to do this whole sub in to find H thing. So we're not done with the equation. We can add a little bit to the question, right? It's the same question with the equation, but we have to sub in and then check to see if my answer is greater than 2 or not. Okay, so let's find, so we're going to find K, and we're going to go 12.5 equals 2 pi over K, and then switch them. Right, so K is 2 pi over 12.5. Now, I definitely don't want a decimal in a fraction. So no decimal fractions. That's like kind of like you merge two things that shouldn't go. So no decimal in a fraction. Does that make sense? So I don't want a decimal fraction. So you either have to get rid of the decimal by multiplying. So you have more than one choice. And again, you know how fractions work. I can multiply the top and the bottom by 10, right, to make it 20 over 125. Or, someone else suggested in the class, can I just multiply by 2, and that would make this a whole number 25, and that by 4. So anything you want, but you're multiplying the top and the bottom by the same amount to get rid of this decimal. My instinct was to multiply by 10, but then, yeah, if you multiply by 2, you don't have to reduce again. Right, so it's up to you. Which one do you want to do, 10 or the 2? Which would you see? 2? Okay, so 2 on top and bottom. So whatever, for a fraction, you're allowed to multiply top and bottom by the same amount. That fixes it, so it's 4 pi over 25, see? And then no fraction decimal, right? You're just not allowed to have a fraction in a decimal, or a decimal in a fraction. Okay, there we go. Let's write our equation then. So let's write our equation and then check to see if it's more than 2 or not. So our equation is going to be f of x equals, or y, f of x I prefer. A is, my amplitude is 4.4. And, oh wait, is it sine or cosine? Does it tell us which one we have to? No, so which one's easier? Cosine, right? So definitely, if I don't make you, then just choose cos, right? If I don't say it has to be sine, then choose the easier one. So cos is no shift. Right, no horizontal translation. Then I'm going to get my K, which is going to be 4 pi over 25 x over, or sorry, not over, and then close that up because then you don't need a translation. And my shift up is plus 5.6. There you go. Right, and then now we're going to sub in, so we're going to go f at, now don't sub in 630. That doesn't match, right? Not 630. What do I have to sub in here? For 630, we started the graph, that's why I like to picture it. So let's look at the graph again. We started the graph at 2, so 630 means, and you have to convert it to hours or minutes, right, depending on what your graph is at. So 630 is how many hours from 2? Yeah.
4:30.
Yes. So 4.5, 4.5. So 4.5. So 4.5 hours, and that's for 630. Does that make sense? So 4.5 hours is for the 630. From 2. I'm going to say from 2 p.m. Right? So from 2 p.m. it goes to 6:30, so that's 4.5 hours, so put 4.5. I know I always get people who just put in 6.5, and you're like, oh no, you have everything beautiful. It's not 6.5. Does that make sense? From 2 o'clock to 6:30, it was 4.5 hours. You have the whole equation there, just watch out. Okay, so plug this in, 4.4 into your calculator. So 4 pi over 25 times 4.5 plus 5.6, right? And I get so many people who put in 6.5. You're like, no, it's from 2 o'clock. Okay, so just be a little careful there. I got, the other class, we got approximately 2.8. Yes? Good. So 2.8. And so, yes, is that higher? So since 2.8 is higher than 2 meters, 2.8 meters, sorry, is higher than 2 meters, the sailboat can exit harbor. Okay, so little explanations, just explaining your thought process, and a sentence, quick sentence. That nice? So it gives you kind of an application. These are always kind of nice because it's like, oh, and then now I can check something with this. There's a purpose to the equation. Nothing, we're good? Clarification? Then the last example is this beautiful chart. Graph it. I'm just kidding. Do not graph it. Do not graph all those points. I only want, do not at all try to, I don't want to see these points. You're not going tick, 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 tick. I just want the max and the min. So just grab 2 pieces of information for this. And we're showing the trend. It is not a perfect graph. It is definitely not exactly sinusoidal. We're just going to use the trend of it. So that's why they said the trend below. So we are saying that it's approximately a sinusoidal. Look, it's not even 100% not, because look, we've got 2 at the same value, right? So it's not perfect. We're looking at it as a trend. That's their way of saying an approximately sinusoidal. So we want to write an equation. That's all. We don't have to check anything, just the equation. And it's a trend below. So we're asking you to approximate that it's going to be sinusoidal. So I just want the max and the min. So max, min, and that's it. So let's grab the max, min, and, oh, and the period. Max, min, and period. So max I've got is 20, right, on this date. So this is my max. My min, I'm going to take the first min, not the second. It'll be about the same, but because it did start here, let's take the first one, because that'll extend my graph a little bit. There you go. Okay. Okay, so max, so this is what I'm going to take as my maximum and my minimum. Okay, and that'll give me enough of a trend. I'm going to take this whole thing here to get me my period. So we know that this is, and again, when you picture it, you do not have to picture it, but I like it. It kind of goes like this. So I know it's down here. My first point will be down here. It's heading up to this point, which is the max, and that's halfway. So remember, that's not the full period. Then it's only halfway. Does that make sense? So it's half. So this, right, so now that you've seen that once, you go, oh yeah, I'm never going to get tricked at that again. People always think here to here is one period. It's not. It's halfway. So from here to here, how many days is that? We got 182 days. And that is this part. So that's only half, 182. So for the full period, I know it's 364. I told you we're approximating the trend. There's 365, and of course the days vary a little bit. There's that decimal day in 365 days a year. We're approximating. Okay, so
use 364?
We're going to use 364, just so based on the graph here. So it's a little bit shorter than a real year. Yeah. So because they gave us the days, right? Because they specifically gave that, I'm going to use 364. I mean, you gave me the specific day. You didn't say halfway or something. So.
The whole cycle of from 15 to from 315 to 15, would that be just
15 to 3.
Like if you look the whole data set.
The whole data set. But again, we're approximating from the max to the min. We're going to say that it's going to extend off. So just use, yeah, max min. Again, there's going to be more than one variation. So this is like an approximate graph.
If I did 365, would it also be right?
That would be okay, but you know, I'm asking you to use this one, so let's just use this one. So I only have to mark one answer. Technically, it's right, because we actually have decimal days, right, in a year. It's never exact. So I'm asking you just give me one one equation, so I can mark the same way. Take this and approximate. Okay, whatever dates we give you.
Always
Is it going to say that in the question?
Well, it depends on what I give you as a question. I won't give you the identical question, but if I use this, try to use the dates, like the days I give
We
you.
should always use max to min, not the whole cycle.
Yeah, exactly, max to min. Yeah, because it's not perfect, right? So see how it doesn't exactly match, and I can't say that it's there. So just do the max min, and take this as my half cycle, and then duplicate it for this. Yeah, right. And again, a trend like this is not perfect, right? So for the benefit of me in marking, that's easier for me. But technically, there should be several answers, right? Like if you were to take this full data set versus that, and et cetera. Yeah. Okay. So for the benefit of me marking, let's do this, and then so then the whole thing would be 364 days. Okay, and that's again just to help me so I can mark it faster. So period would be 364. So then find the K. So I'll go ahead and find the K, and we're going to go 364 equals 2 pi over K. K equals 2 pi over 364, which gets me pi over 182. And again, right, so in reality, what would we take as our full data set, the whole year or not? This is okay. 182. Do I have everything I need? Oh, wait, is there a shift? Does it say which graph I have to do? Sine or cosine? No, so let's choose the easiest, which would be what? So what would my parent function be? So for me, my parent function would be y equals negative cos. Wouldn't that be nice? Then I just have to do the negative, and then I don't have to do a translation. Does that make sense? So you get to choose your parent function. I'm going to choose the negative, and then I don't have to do a translation. Again, you could have translated it, and I would accept that as an answer. Yeah, for sure.
What you're finding is
Yep. Yeah, so you could do the sine graph, you could do the cosine graph, you could do...
I did cosine, but I shifted it right 15 because I'm saying my graph is starting from day 0 and that's at 15.
Oh, yeah, exactly. Yeah, so you could also, so depending on where you start your graph. So if I start here, yeah, exactly. So there's more than one way. So for this one here, I'm going to start it on day 15. So this is January 15. So this day here for me is January 15. You could do the same graph. So I'll say or. You could do the same graph and it was starting here, right? And this is the 15. So you would have a shift over a 15.
Plug in the numbers.
Yeah. Yep, and all you're doing is shifting at 15.
So which one's right?
No, they're both right. So it depends. So when I ask you a question, though, if I say what is happening on day 30, right, if you chose this graph, you would put in 30. If I chose this graph, I would put 15 because it's starting from day 15. Yeah, right? So they're both totally fine. They're just depending on if I ask a secondary question and say what's happening on January 30 or 30 days of the 30th day of the year, then you would put, for mine, I would put 15, and for this one, you would put 30. Yep. So both good, both wonderful. You just have to know how to work each graph, right? So depending on your starting graph, you would continue. This question doesn't ask you for a secondary question, right? It could. This one doesn't. So it would depend on your initial equation. Okay. So I'll do it from this one. But yes, there's more than one possibility. Good? Okay. So for this here, I'll just do the equation. So f of x equals, I'm choosing the parent function, the negative, because this is going to go upside down. So I'm going to put the negative, and it's going to be cos. Oh, wait, amplitude. Oh, did I do my amplitude? I forgot to do my amplitude. So my amplitude is 21.9 minus negative 4.8 over 2, which is 13.35. I'm just going to separate this so you can see. And my period, or sorry, not my period, my axis. Sorry, I started my equation before I finished. My axis is when I add it, so 21.9 plus negative 4.8. Divided by 2, and I get 8.55. Okay, so now I have everything. And we've got some negative. So if I'm choosing the parent function negative because I'm starting upside down and I'm starting it at the axis, then my defining equation would be starting on January 15th, right? So on the 15th day of the year, If you did it this way, you would start at January 0, right? Would be January 1st, and then you would have 15 as a shift over. And both are good equations, right? And I know which is which. So this one's going to be amplitude 13.35. For me, it's cos, and then I'm going to use my k, so pi over 182x, no shift for me, plus 8.55 done. You want me to do an equation if I shifted it? Yes? Okay, so if we shifted it, and this was starting here, so this would be my